In 1969, NASA built a rocket so powerful it could hurl 130 tons to the moon. Today, we cannot build another one. Not because we chose not to. Because we forgot how. The blueprints still exist. Over 3 million pages of technical documentation sit in archives. But the engineers are dead or retired. The contractors went bankrupt. The factories were demolished. And scattered across those millions of pages are thousands of tiny decisions. Shortcuts. Workarounds. Tribal knowledge. That were never written down at all. This isn't a NASA problem. This is a humanity problem. We like to imagine knowledge as a one-way ratchet. Once discovered, forever known. But that's a comforting lie. The truth is far stranger and far more disturbing. Human civilization is a leaky vessel, and we keep losing the instructions for how to patch the holes. Roman concrete that grows stronger in seawater. Medieval stained glass with colors we cannot reproduce. Greek fire that burned on water. Damascus steel that could cut through rifle barrels. Gone. All of it. Not destroyed by invaders. Not burned in libraries. Just forgotten. One retired engineer at a time. One closed factory at a time. One generation at a time. How does this keep happening? And more importantly, what are we forgetting right now? Let's start with the most insulting example. Roman concrete. The Pantheon in Rome has stood for nearly 2,000 years. Its dome remains the largest unreinforced concrete dome ever built. Roman harbor structures have spent 2 millennia underwater and actually gotten stronger. Meanwhile, modern concrete starts crumbling after 50 years. Sometimes sooner. For centuries, scientists assumed the Romans just got lucky, or that we were missing some obvious ingredient. But the recipe was right there in ancient texts. Volcanic ash, lime, seawater, rock. We tried it. It didn't work. Turns out, the secret wasn't in the ingredients. It was in the process. In 2023, researchers finally cracked it. Roman concrete contains small white chunks called limeplasts. For decades, everyone assumed these were mixing failures. Sloppy quality control. They were actually the key to everything. The Romans used quicklime, ite that hadn't fully reacted with water. When cracks formed, water would seep in, react with these lime chunks, and literally heal the concrete from within. Self-repairing infrastructure. 2,000 years ago, the recipe was never truly lost, we just couldn't read it properly. We saw the words but missed the music. But here's what should terrify you. If it took us this long to decode Roman concrete, what else are we looking at without understanding? Walk into Chartres Cathedral in France. Look up at windows installed 800 years ago. That blue, that specific, luminous, seemingly lit from within blue. We don't know how to make it. We can analyze the glass. We know the chemical composition down to parts per million. Cobalt compounds, potassium, silica. We can list every element. And we still can't reproduce it. Because knowing what something contains is not the same as knowing how to make it. The medieval craftsmen didn't write formulas. They learned by doing, by standing next to a master for 10 years, by developing intuitions they couldn't articulate, by making 1,000 mistakes until their hands knew things their minds couldn't express. This is called tacit knowledge. And it's the silent killer of technological continuity. Michael Polanyi, the philosopher who named this concept, put it perfectly. We know more than we can tell. Think about riding a bicycle. You know how to do it. Now try writing instructions precise enough that someone who has never seen a bicycle could learn. From text alone, you can't. Some knowledge exists only in the doing. The stained glass masters had tacit knowledge. When they died, it died with them. But surely modern documentation solves this problem? Surely we record everything now? Let me tell you about the F1 engine. The F-1 was the most powerful single-chamber rocket engine ever built. 5 of them powered the Saturn V's first stage. Each one produced 1.5 million pounds of thrust. In 2013, NASA decided to study the F-1 for potential use in future rockets. Engineers pulled pristine engines from museums. They had the original blueprints. They had the specifications. They had everything. Except they didn't. The blueprints showed what to build, but not how. They didn't capture the welding techniques that only existed in the hands of specific technicians. They didn't record the hundreds of small adjustments made on the factory floor. They didn't preserve the institutional knowledge of why certain design choices were made. One engineer on the project put it bluntly: trying to rebuild the F-1 from documentation was like trying to learn to cook from photographs of finished dishes. NASA ended up having to reverse engineer their own technology. They CT scanned museum pieces. They built test articles and failed. They essentially had to rediscover techniques that had been routine 50 years earlier. And here's the uncomfortable part. This happened within living memory. The engineers who built these weren't ancient Romans. Some were still alive. But institutions don't remember. People do. And people leave. Now imagine what we're losing in fields that don't have museum pieces to CT scan. Damascus steel was legendary. Swords that could cut through European blades. Flexible enough to bend 90 degrees without breaking. A distinctive wavy pattern that smiths spent lifetimes trying to replicate. By 1850, no one on Earth knew how to make it anymore. The technique had been passed down through generations of smiths in the Middle East, then supply chains shifted. The specific ore from India that contained the right trace elements became unavailable. And without that ore, the smiths couldn't teach the next generation, even if they wanted to. Their knowledge was entangled with a material that no longer existed. Modern metallurgists have spent decades trying to reverse engineer Damascus steel. They've gotten close. Carbon nanotubes, specific forging temperatures, controlled cooling rates. But debates continue about whether any modern attempt truly matches the original. Greek fire was even more dramatic. A weapon so secret that the Byzantine Empire executed anyone who tried to share its formula. It burned on water. It clung to ships. It terrorized enemies for centuries. Then the empire fell, and the secret keepers died without successors. Mission accomplished. In the worst possible way. Sometimes we lose knowledge through carelessness. Sometimes through catastrophe. And sometimes through security so tight it becomes a suicide pact. In 1901, divers found a lump of corroded bronze in a Greek shipwreck. It sat in a museum basement for decades before anyone realized what it was. The Antikythera mechanism, an analog computer built around 100 BCE. It predicted eclipses, tracked the Olympic Games, modeled the motion of the moon with corrections for its elliptical orbit. It contained differential gears, technology we thought was invented in the 16th century. Nothing else like it exists from the ancient world. Not because the Greeks couldn't build more. Because we have no idea how they built the first one. This wasn't a one-off fluke. This was clearly the product of a sophisticated tradition of precision metalworking. A tradition that developed over generations. A tradition that vanished so completely we didn't believe it had existed until we held the proof in our hands. How many other mechanisms were built and lost? How many other traditions peaked and vanished without leaving a single artifact? The Antikythera mechanism survived by accident. A ship sank. Conditions preserved it. Divers happened to find it. We got lucky. History is the record of what survived, not what existed. And the gap between those two things should keep you up at night. Let's bring this forward, way forward, to right now. The semiconductor industry runs on machines called EUV lithography systems. Only one company on Earth makes them. ASML in the Netherlands. Each machine costs $200 million. They use light with wavelengths of 13.5 nanometers to print circuits smaller than a virus. If ASML's factory burned down tomorrow, no one could rebuild these machines quickly. Not Intel, not TSMC, not Samsung. The supply chain involves thousands of specialized components from hundreds of companies across dozens of countries. The knowledge isn't in one place. It's distributed across a network so complex that no single person or organization understands all of it. This is the modern form of vulnerability. Not lost scrolls. Not dead craftsmen. Interdependence so extreme that catastrophic forgetting could happen through economic disruption alone. We've distributed our knowledge for efficiency. But efficiency and resilience are often opposites. Companies that made vacuum tubes shut down because transistors won. Fine. Progress. But what happens when we need vacuum tubes for specific military or aerospace applications? We scramble to find retired engineers. We pay fortunes to resurrect dead production lines. We keep building civilizational single points of failure and calling it optimization. Why does this keep happening? Because knowledge preservation is expensive and forgetting is free. No one budgets for institutional memory. No quarterly report measures tacit knowledge retention. No executive gets promoted for ensuring the company still knows how to do things in 50 years. The time horizons don't match. Human careers last decades. Human memories last less. But civilizational knowledge needs to last centuries. There's also the problem of legibility. Written knowledge gets preserved because it's visible. Tacit knowledge is invisible until it's needed. And by then, it's often too late. Think about your own organization, your own field. How much crucial knowledge exists only in the heads of people approaching retirement? How much has already walked out the door? The Soviet Union had entire closed cities dedicated to nuclear weapons production. When the USSR collapsed, scientists scattered, some to other countries, some to poverty, some to graves. How much was lost? We may never know. That's the point. Every bankruptcy, every merger, every reorganization is a potential extinction event for knowledge. We just usually don't notice because the effects are delayed. The forgetting happens silently. The consequences arrive loudly, years later, when it's too late to ask questions. Is there hope? Maybe. But it requires treating knowledge preservation as seriously as we treat knowledge creation. Some organizations are trying. The Long Now Foundation builds clocks designed to run for 10,000 years. Partly as a statement about thinking on civilizational timescales. The Internet Archive captures snapshots of the web before pages vanished forever. The Arctic World Archive stores data in a decommissioned coal mine in Svalbard. But these are exceptions. Passion projects. Not the default. The deeper fix is cultural. We need to value transmission, not just discovery. Science celebrates breakthroughs. It rarely celebrates the patient work of documentation and training that ensures breakthroughs survive their creators. We need to record not just what, but how. Not just formulas, but processes. Not just blueprints, but the judgment calls that blueprints leave out. And we need humility. The Romans didn't know their concrete was special. They just made concrete. The Damascus smiths didn't know their supply chain was fragile. They just made swords. We are certainly making things right now that we don't realize we're making. And we are certainly failing to record knowledge that seems too obvious to write down. Future generations will look back at our era and ask how we could have been so careless. Here's the question that haunts me. We think of progress as a ladder. Each generation climbs higher than the last, but what if it's more like a treadmill? We're always running just to stay in place. Always rediscovering what our ancestors knew. Always one disruption away from losing what we just learned. The Library of Alexandria burned. But more knowledge has been lost to simple neglect than to all the fires in history. Somewhere right now, an engineer is retiring with secrets they don't know are secrets. Somewhere right now, a factory is closing with techniques that exist nowhere else. Somewhere right now, we are forgetting something that will take decades to relearn. Or maybe we'll never relearn it at all. So here's what I want you to think about. What knowledge do you have? In your field, your craft, your family, that exists nowhere.